Chapter 1 review, man. Let's get ready for the test. This test, you can use the calculator on the whole thing. So in the future, there may be some no calculator sections, but not today. So let's jump right in. Let's get after it. So number one, we're trying to simplify. So all of these problems, until the directions change, are simplifying the expression. So we have to simplify some radicals. We need to add radicals, and they have to be like radicals. So since this one on the left is radical 3, I'm going to try to rewrite the one on the right with a radical 3 in it. And so I have to ask myself, 3 times what gives me 75? Well, I can do the square root of 25. And that helps me out because that square root of 25 is just 5. So now I have negative 2 radical 3 plus, this is really just 5. So then I have 5 radical 3. And I can put it in the front or in the back. We're multiplying, so commutative property says I can go either way. And now I'm just going to add them up. Negative 2 radical 3s plus 5 radical 3s is a grand total of 3 radical 3s. Again, keep the radical 3 along for the ride, almost as if it was a variable. Number 2 is a little trickier at subtraction. 24 will not go into 54. So I'm going to try to find the greatest common factor, the GCF, which in this case, I think the biggest number that goes in there is 6. So I'm going to rewrite this as the square root of 4 times the square root of 6. So that's 24. And then this one is going to be the square root of 9 times the square root of 6, which is 54. And now I have a couple perfect squares there. So I have 2 radical 6, subtract 3 radical 6. And 2 take away 3 is negative 1 radical 6. And usually they don't leave the 1 there. So if this was a multiple choice test, you'd probably just see that as your answer. All right, moving right along, going down the page. Number 3 and number 4. Well, number 3 is just a normal algebra expression. So I'm going to distribute, and I get negative 8x. Distribute, positive 4. Be very careful here. Whenever there's a minus sign in front of a parentheses, treat it like a negative 1. So I'm going to distribute. I get negative x. Distribute. I'm going to get positive 3. And now I'm going to gather up some like terms. Negative 8x is negative 1x. That's a negative 9x. And then positive 4, positive 3. That's a plus 7. And that's as far as we can go with it. Number 4, this is properties of exponents. It looks like it's all just multiplication. And there is no distributive property. I know some of you guys right here are thinking, well, maybe I got to start distributing all of these a's and b's. The distributive property is for when you have something either plus or minus inside parentheses with a term on the outside. Everything inside there is multiplication. So this can just be multiplied out. You could almost think of it as like 8 times a squared times b to the 5th times a negative 2 times a to the 3rd times b squared. It's all multiplication. There is no subtraction or addition. So now the order is up to me how I want to do it. I'm going to do my coefficients first. I'm going to get a negative 16. Then I'm going to do my a's. A squared times a to the 3rd, you add the exponents. And then b to the 5th, b squared, add the exponents. I get b to the 7th power. All right, moving right along. Number 5 and number 6. So number 5, I'm raising a power to a power. So everything inside these parentheses here need to get raised to the 4th power. So I'm going to do this separately. I'm going to do the negative 2 raised to the 4th power. Be sure to put parentheses around it if you're using a calculator. Then I have to do x to the 3rd raised to the 4th. And then I have to do y squared raised to the 4th. And be careful here. Negative 2, any negative number times an even power is going to be positive. So negative 2, it's going to be 16 positives. This will be x to the 12th, and that will be y to the 8th. And as long as I don't have any negative exponents, I'm simplified, I'm good to go. Number 6. we're dividing now. So there's a couple different ways you could do this. In general, the rule is, if you have some base to the a power divided by the same base to the b power, you are allowed to subtract the exponents. So I could do that. I might show you a little bit different way, but either way, it could work. And just ask me in class if you did it a different way and you'd like to see it done that way. But 28 divided by 4 is just 7. So that reduces to 7 over 1. I don't like that a to the negative 2 on top. So the way I do it is I throw it on the other team. I'm going to throw that a to the negative 2 on the bottom. So I already have an a squared down there. I'm going to add in the a squared from the top. So I threw him to the bottom. The b's are okay where they are because they're positive. And now I just got to do some canceling. So I kind of think of it, you're going to war here. There's people on top, people on bottom. They're going to cancel each other out. So I have 3 of these b's on top, 2 on bottom. 2 of these are going to get wiped out with 1 of those left. So there's a b on top. Down here, I have a to the 4th. And usually we don't include the 1. So there's the correct answer, 7b over a to the 4th. If you wanted to, you could have just been a rule follower. Did 28 divided by 4 is 7. Then you could have subtracted the exponents. You just got to be careful. It's a to the negative 2, subtract a positive 2. And then b to the 3rd, subtract a positive 2. It's usually when it's a negative on bottom, people mess up when they minus a negative. So if I'm doing this way, this would actually be 7a to the negative 4th, and then b to the 1st. But then you'd have to fix it, and you'd have to do, the reciprocal of a, or 1 over a, to the positive 4th. So either way, you get to the same place. I just like fixing negative exponents early in the problem. All right, again, a couple different ways to do this problem. I've probably shown it different ways in class, so it's just kind of up to you. I'll do this one traditional. So I'm going to just raise every piece to the negative 2 power. So I'm going to raise 5 to the negative 2, and I'm going to do x to the 4th to the negative 2, and then I'm going to do y to the negative 3rd raised to the negative 2. And I'm just going to follow my rules. So negative exponents, to fix a negative exponent, you do the reciprocal and you make it positive. So technically the reciprocal of 5 is 1/5. And then you make it positive, which 1/5 times 1/5 is just 1 over 25. So sometimes it might be easier to think of it as just make the 5 to the negative 2, just make it positive and put a 1 on top. And you'll also get 1 over 25. So different ways to look at it. So this is 1/25. This is going to be x to the negative 8th, because raising a power to a power you multiply. Negative 3 times negative 2 is 6. So that's where we're at right now. And the only issue is I need to get that x to the negative 8th on the bottom to make it, because it's positive. It needs to be positive. It's on the wrong team. So I believe that would be your final answer. All right, moving right along, number 8. I'm going to grab my calculator here. Actually, I don't have to grab my calculator on this one. So this is scientific notation, and I'm going to divide these two out. So this part I just do normal division. 7.7 divided by 1.1 is 7. Now I'm going to do my powers. If you want to just, you could fix them by either putting the negative 2 up on the top, or you could just do 5, take away a negative 2 if you want to follow the rules. Either way, you get 7 times 10 to the 7th power. So that would be the answer for that one. Scrolling on down to the next couple. All right, this one I am going to cheat, and I am going to grab a calculator over here. And So I have 4.7 times 10 to the fourth multiplied by the other one. So what I'm going to do is I'm going to do these coefficients, not coefficients really, but the numbers by themselves. Times those two together, I get 15.04 times, well, when I do 10 to the fourth times 10 to the negative 8, I add the exponents, and I get 10 to the negative fourth. Now this is wannabe scientific notation because this front number here needs to be between 1 and 10, and it's not. So I need to fix that. So to make it be a number between 1 and 10, I need to move this decimal 1 to the left. Now I've just made that number smaller. So to keep this balanced, if I made that number smaller, I need to make this side bigger. So I need to add 1 to make it bigger by 1. So now things should be balanced out. I have a number between 1 and 10, and I am good to go. All right. Number 10, which of the following is the range of the function? So make sure you know the difference between the domain and range. So remember, the domain is the input or the x values, where the range is the output or the y values. So I need the y values because it's the range. So I have 4, 3, 3, 4. So all we have are 3 and a 4. Correct answer here is C. You don't have to write repeats for domain and range. All right, number 11 says, is the relation shown in the table of function? So what has to happen is every input can only go to exactly one output. So I think I made a reference that x's can't cheat, like the x's have to be paired up. And, 10 goes with 2. I don't see, well, I got a couple problems. If I were to map this out, I have an input of 10, just went to 2, but then it also went to 10. That's a problem. There's another problem with 9. 9's cheating. 9 mapped to 4, and 9 also mapped to 8. That's another problem. So this is a big fat no, not a function. There is an x that got mapped to 2 different y's. Can't happen. Number 12 is the relation shown in the graph a function. So if you have a graph, there's an easy way to test it called the vertical line test. And you simply just draw vertical lines. And if you ever touch the graph twice, then you know it's not a function. And anywhere where I draw a vertical line, I don't see myself crossing the red line more than once, anywhere. So I think this one passes yes. This is also a function because of the vertical line test. Number 13. So this is function notation. Remember, this is the input. If f of x is, and that's the rule, negative 3x squared plus x, then evaluate f of negative 2. So basically, they're just saying, hey, make x be negative 2 and see what y equals. Because remember, f of x, this whole thing, that right there is really just y. And this is the x part. So it basically says, hey, drop negative 2 in the equation, see what it equals. So I stick negative 2 in place of x. I got to stick negative 2 in place of that x. And now I have to follow the order of operations. Do exponents first. A negative 2 squared is 4. Got to bring everything else down. Negative 3 times 4 is negative 12. Add that to a negative 2. Gives you a grand total of negative 14. So I would write that as f of negative 2 equals negative 14. All right, move on down to number 9. I think I had a little typo on number 9. I apologize. But it says if g of x equals 3x minus 8, then evaluate. This should have been a g. I think I corrected it in class, but if not, correcting it now. And just like up above, where I plug negative 2 in, I got to plug this whole expression, this whole negative 4x, everywhere where I see an x. So instead of x, I got to plug in negative 4x. And I'm not going to get a value as far as a number. I'm going to get an expression, which is negative 12x subtract 8. So that's what g of negative 4x gets. You drop negative 4x in the machine, this is what will get spit out. Number 15. This one says the points negative 6, blah, 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 are on the graph of a function. What are the coordinates of the 3 points after a horizontal stretch? A horizontal stretch by a factor of 3. Well, let's just visualize. I don't really want to plot all those points, but let's just kind of think about what happens. Let's just say, and I'm going to kind of use this grid over here. So kind of make up just a fake type of problem. And this is a y-axis and this is an x-axis. Well, if I pick a horizontal stretch, first of all, I'm stretching things horizontally. So I'm pulling outward in each direction. I'm kind of grabbing it and extending my arms out and yanking it out. So imagine a point that lives like, let's say right here. That point's called 2, 1. Well, after I stretch it out, let's say I stretch it by a factor of 2. All right, let's say I stretch this thing by a factor of 2. That means I'm going to yank it twice as far from the y-axis. So that means that instead of being 2 spots away, I'm going to yank it out twice as far, and the new point is going to live out here, and it's now going to be double that. It's now going to be 4 spaces away. So the new place is going to be at 4, 1. That's going to be the new position. So when I analyze what happened, well, if I horizontally stretch it, I'm basically making the x-coordinate get doubled. So I'm going to multiply x by 2 on a horizontal stretch. So we just got to multiply all the x's by 3. So multiply that by 3, I get negative 18. Multiply this by 3, I get 0. Multiply this by 3, I get 9. And that looks like we match up perfectly right there. So that's a horizontal stretch. Number 16 is segment with endpoints at negative 1, negative 3, and 3, 2 is on a graph. Which of the following would be an endpoint if the segment was reflected across the x-axis? So let me just sketch this out. It's not very big. I'm going to put my points on here. So let's just go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And let's put these current dots on there. So negative 1, negative 3. That's right there. And then 3, 2 is right here. So there's my line. And that's going to get reflected across the y-axis. So if here's my y-axis, every point's got to jump across the y-axis. So this point up top at 3, 2 is going to jump over here. You know, it's going to go jump over there. And then this point is going to jump 1 unit across over here. And now I'm going to have a reflection across the y-axis. And my new endpoints are going to be 1, negative 3, and negative 3, positive 2. So it says, which of the following would be an endpoint? So I need 1, negative 3. Ooh, I see 1, negative 3 right there. The other possible answer could have been negative 3, positive 2, which the other ones are close, but not it. 17, this one's easy. Identify the parent function. Well, because it has a power of 3, and that's the biggest power, it makes it a cubic. So the answer is C. Remember, quadratic, the biggest power is going to be squared. Linear, the biggest power is going to be x to the first. Cubic is x to the third. Square root's pretty easy because you're going to see a square root symbol in it. Number 18, graph the relationship from. So from means that's the x. So time is the x. 2, that's the y. That's where we're mapping to. The number of organisms. So time is x. Organisms are y. Identify the parent function. So we kind of put this on the grid, and this grid isn't that big, so I'm going to kind of improvise a little bit. Sometimes you have to do that. Sometimes your numbers are big and you got to change the scale a little bit. So let's just go like this. And on bottom, I got to go to 4. So I don't know, maybe I'll just do 1, 2, 3, 4. And then when I go the other way, I got to go to 16. So maybe I'll count by 2s. 2, 4, 6, 8, 10, 12, 14, 16. And I got to put these dots in. So 0, 4, going to be right here. 1, 8, it's going to be right there. 2, 11, right here. 3 to 12, right there. 4, 16. So this to me, you know, it's not going to be perfect because it's modeling. It's not like an exact science here. It's kind of looking to me like this is just going to be a line cutting through here. I'm not seeing like a sharp uptick like a quadratic or a cubic would do. You know, both x cubed or x squared takes off that way. You know, x squared would keep going back up. X cubed would kind of come back down. But I'm not seeing that sharp uptick. I'm also not seeing the square root thing where it kind of goes over and flattens off. So I'm thinking this one's going to be linear. I also could do the common differences that we talked about in class, and I could kind of compare it that way. But that it doesn't match up perfectly because it's a model, so can't really quite do that on this one. All right, number 19. The function h of t is 20t minus 5t squared gives the height of an object t seconds. So t is my time. So that's my input. So my input is the number of seconds. And h is the height. So h of t, that basically tells me the height, the h of t is. So which statement is true? At a height of 4 seconds, it's the same as 2 seconds. Height at 2, is that the same as 3? So I got to plug in a bunch of different seconds. I got to plug these in here and see what the heights are. I think this is a good job for the graphing calculator. So let's come over here to the graphing calculator and let's bring this guy up and kind of pull him down. And let's do this. Let's put in y equals, so I'm going to turn it on and turn it on again. There she is. And I'm going to go 20t, 20x, I'll just use x because it doesn't really matter, minus 5x squared. I said x squared. And enter, lock it in. And now let's go to our table. I want to get some table values. The second graph, I got a table. So now I see my seconds. So I'm going to write these over here so that we have them. So t is my seconds. H of t is the height. And here's what we're going on. We got 0, 1, 2, 3. It doesn't look like we go past 4 seconds. So that's all that important. So at 0 seconds, it's at 0 height. After 1 second, it went up to 15. 2 seconds, it kept going higher to 20. Well, then at 3 seconds, it was back at 15. And at 4 seconds, we're back to 0. So if you graph this thing like against time, well, I could just kind of show you. If I click on this and go to graph, you can kind of see that this thing goes up and down. It's a little bit out of my window because my graph is only going up to 10. So if I change my window, and maybe for x, I just want to see between 0 and 5 seconds. So I'm going to go 0, 5. And the y's, I now know they go all the way up to 20. So I'm going to go 0 to, I don't know, maybe I want to go to 25. And I'll just hit graph. Now I'll see a little better picture of what's going on. So that's kind of the height of an object being thrown. But when I go back to my table to answer the question, is the height at 4 seconds the same as 2? No. Is the height at 2 seconds, 20, the same as at 3 seconds, which is 15? No. Is the height at 3 seconds, which is 15, the same as 1? Yes, those are both 15. I think C's right. Let's check 4. Is the height at 4 seconds, which is 0, the same as the height at 1 second? No, that's 15. So correct answer there is C. All right. Number 20, SAT type question. The graph of x is shown. What is the value of f of 0? So this is a y value. They're saying what is the value of y? And they're telling me that x equals 0 because that's x is the input. So they're saying, hey, when x is 0, what does y equal? So I go to my graph. Here's x equals 0. I go up, and it looks like it's going to be right up there at 4. So correct answer here is 4. Going over the other side, final question. I have this graph, and see if I can get it all on there. Oh, let me shrink it down a little bit. We'll go down to like 150. Think that'll, let's go down to 125. Now we can see it all. So I chose this question because SAT does this style. I want you to get familiar with it. So it says the complete graph of the function is shown in the xy plane above. Which of the following is equal to 1? Now, this is a y value. So they want to know when is this thing, which one of these guys are equal to 1? Well, let's go through and figure out what they all equal. So f of negative 4, so remember these are x's. So when x is negative 4, that's, let me kind of darken our coordinate. This is the x-axis. This is the y-axis. All right? So let's go through and let's kind of figure things out. At negative 4, 1, 2, 3, 4, well, it looks like the y value was 1. All right? So that one equals 1. F of 3 halves, aka 1.5, well, when x is 1.5, yep, it looks like the value is 1. And when x is 3, guess what? It's also 1. So it looks like which of the following is equal to 1? Roman numeral 1, 2, and 3, it's all of them. All right? And those questions, for some reason, just trip kids up. Sometimes in other questions, they wouldn't all be 1. Maybe it'll just be 1 and 3 or 1 and 2 or just number 2. So these type of questions I just want to get you familiar with this year. So when you take the SAT, you will be ready for it. All right, hopefully this review prepares you for the test. If you have questions, as always, ask me in class. See you.